Hi guys, gonna make a couple more videos here for you guys. Hopefully you don't ever have to watch one of these again. Then I won't be gone so much anymore. But today we're looking at two theorems that are going to take stuff we've been working on like synthetic division and start applying them to work on problems, factor problems, solve problems that normally in the past we haven't been able to factor or haven't been able to solve. So that's what today is all about. But most of it should be pretty straightforward. We're going to be using synthetic division and factoring to accomplish this goal. So hopefully this goes well for you. So what we're going to start with is the remainder theorem. It says that if a polynomial is divided by x of k, or x minus k, then the remainder r is equal to f of k. So basically, what we're looking at here is if we want to divide this this polynomial by x plus 5, that the remainder is equal to if we plugged negative 5 into the function. So it's basically how we learned to do synthetic division, how it was related to synthetic substitution. So you'll kind of see what I'm talking about here in a second. So just remember that when we divide by x minus 7, that what we're plugging in, again, that idea is that we need to switch the sign here. So that's positive 7. Or if we're going to divide by x plus 4, then we actually switch that sign. So we're plugging in negative 4. So just remember that sign switch. We've talked about that in the past. When we go to do the synthetic division, we have to switch the sign of the divisor. Of course, one of the other big things we have to remember when we do synthetic is to look at the dividend and identify if there's any gaps in that problem. And definitely see that there are no x squareds here in this problem. So as I go to write the synthetic division box, or the synthetic substitution box, I'm going to make sure I put a 0 in there. So I've got a 1, 4, 0, 16, negative 35. And just like we were talking about here, make sure that our k value is negative 5. So what we're plugging in, what we're evaluating this function at is negative 5 when we try to divide by x plus 5. So I'm going through that math real quick. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and add. So we get a remainder of 10. So what the remainder theorem says is that this value is equal to f of negative 5. So this is kind of reestablishing that connection we talked about already of how this value here is important, how it's connected to this division. The remainder of the division is the same as if we plug this number into the function. That there is a connection there. And the other thing we talked about is, if I did want to say what does the division give me, that's my remainder, that's my constant, that's my x, this is my x squared, and the highest thing I have would be x cubed, which should make sense because x to the 4th divided by x would give us x cubed. So I think it's 1x cubed minus 1x squared plus 5x minus 9 plus 10 over x plus 5. Again, the remainder theorem is just about how these, why did I write negative 10 there? How these two things are connected. So that's what this theorem is all about. All right. So we can take that and we can transition it into this idea of what does a remainder mean, or what if it means if there is no remainder, if the remainder is 0. What does that mean about what we're doing? So if we look at something, and just go back to numbers here really quick, let's say, what does it mean? What do we get when we divide 100 by 6? So I say, 6 goes into 10 once, That gives me 6, subtract the 6, 4, bring down the 0, 6 goes into 46 times, which is 36 minus, so this gives me an answer of 16 and 4/6, which I know can be reduced, but let's leave that for that right now. So when we think about what is 100 divided by 16, it's 16 and 4/6. Well, what if we look at something like what's 72 divided by 6? Of course, 6 goes into 7 once, which is 6, subtract, and say 1, bring down the 2, get 12, and then 6 goes into 12 twice, which is 12, and 0. So this one has no remainder. So what does that mean? What's special about this problem having no remainder? What that means is that since the remainder is 0, or there is no remainder, then the divisor, in this case that'd be 6, is a factor of the dividend. Of course, finding factors is something we're very interested in. So if we can divide something by something else and get a remainder of 0, then our divisor, the thing we're dividing by, must be a factor of the thing we divided. So 6 is a factor of 72, whereas 6 is not a factor of 100. Okay. So we have this new theorem that's based off that idea. It says a polynomial has a factor of x minus something if and only if f of k equals 0. That when we plug in that value, that k value, we get 0 as a remainder. So it's basically telling us how we can use synthetic evaluation or synthetic substitution or synthetic division to see if something is a factor or not. So that means if we know one factor of a polynomial, we can find the other factors, or if we know one zero of a polynomial, we can find the other zeros, or if we know one solution of the polynomial, we can find another solution. Remember we talked about not too long ago, and again last semester also, that zeros and solutions really are the same thing. Okay. What we're mainly going to be focused on is that if we know a factor of the problem, we'll be able to find the other factors, or if we know one of the zeros or the answers to the problem, we'll be able to find the other zeros or answers. So that's how we're going to be applying this theorem today in conjunction with the remainder theorem to be able to factor problems that we wouldn't normally have been able to factor, or solve problems that we wouldn't normally be able to solve. We'll do an example of that on the next video.